Alrighty, this is week number 7 of the first semester of the 2025-2026 NHA school year, Algebra 1 with yours truly, Mr. Soto. We got just a fraction of the normal students on. I think others will be joining us a little tardy, and others might have obligations. I know there's a play going that people have tech week for a homeschool play in both of my classes, or in two of my three classes, I should say. And then also, maybe there's some testing going on because my first class we're missing some students. However, the good thing about today is this. Today is going to be very, very, very simple from what we normally do. And it's interesting in my pre-algebra class, which I just taught, it was by far the hardest thing we've done all year. And I told that class, as I told our class, that the first 15 or so lessons are very review oriented, and we put those under the umbrella of a little easier than the stuff we're going to be advancing into later in the semester. And so I told you, and I told them also, that you should uh, appreciate the easier work because the easier work is review oriented. It will get harder. Okay. So today in pre-algebra, it was very, very difficult. The most difficult stuff we've done all year, probably the most difficult stuff they've ever done in their math career. Contrasted with your class, and your class is actually going to be, especially the first lesson 29, is the easiest thing you've done. This is so easy. And so it's only going to take us 5 minutes to get through lesson 29 because it's so easy. And that's a good thing because it's going to get harder. I told you around Thanksgiving is when it's going to get, a little bit tougher. And we're not quite even to Halloween yet. So, or the Halloween time. I know maybe some of you don't celebrate Halloween or Thanksgiving. That's fine if you don't. But those time stamps that we recognize. So this is actually going to be very, very, very simple lesson 29. Lesson 30, a little tougher, but still simple nonetheless. Let me get a drink of water. Let me put on the white screen here. If I go to multi view, then I go to the white screen. It gives me a bigger uh, my screen's a little bit bigger for the video at home. And so when I'm here teaching you live, you can see my cursor bouncing around, but that little cursor that bounces around doesn't, for whatever reason, doesn't record. And so, and that basically the way it records it, like it just kind of appears, it's just a little different. Like if I write like this, you see it instantly, but it comes in like spurts on the recording. So if you're watching this after the fact, the recording isn't a perfect rendition. And so I try to be mindful of that for you. So in lesson number 29, as I mentioned earlier, it's relatively easier stuff. We have about half the class here today. So I'm kind of glad that on a day that would be deemed a little easier, because I want you to always hear, especially when the material gets harder, it's good. It's better for you to be on live in case you need to ask a question. And I told you the video is better live than the recorded, but you still can catch up if you ever do miss a Thursday as well. So we're going to be talking about rates, which are based on ratios and on proportions and such. And you can do rates and proportions a couple different ways. You can do them as a fraction, or you can do them with a colon. For example, let's show you number 1, and I'll go ahead and read this for you. It says it takes an auto shop 30 minutes to do an oil change. Find the rate per minute at which the shop can do an oil change. Okay, so again, if you see the little article and the are called articles, and a or an oftentimes implies just one, like an elephant or an ant. Here it is an or a oil change, so it's one. So it takes an auto shop 30 minutes to do an oil change. The ratio can be expressed one of two ways. 1 with a colon to 30, or 1 to 30. Now, you'll need to know ratios later on and how they work with proportions. And as I've taught you already, anytime you have a fraction separated by another fraction with an equal sign, you could always cross multiply. Now, this doesn't work out because it's not equal to each other, but you can cross multiply if it were equal. Here, it's not proportional because there's not equals. So when you have two fractions that are proportional, they should be equal to each other. And I should have better put it this way: 1 to 30 is equal to 2 to what? And then you can cross multiply and x equals 60. And that would be a proper, I just put a value there. I just randomly throw in arbitrarily numbers in, but you can solve that way, mathematically speaking, because they're proportional. I call this method one of two things: either the Band-Aid, because it kind of looks like how you think of a Band-Aid, and like that. Like Band-Aids are sometimes referred to with just crossing like that, or a butterfly, because it kind of has a butterfly, you know, look to it or something. I don't know. That's the worst rendition of a butterfly I've ever seen. Sorry about that. And I should get a hash mark just for that ugly butterfly. But I'm not going to, because that would be unfair. So the answer to number one is simply 1 to 30, like a fraction like that, or 1 to 30 as with a colon. Either of these are expressing proportions or ratios. All right. Number two, not to get any harder, it's all this easy. You find what your numerator is, and then you find what your denominator is. Let's look and see if we can figure this out. Mark can mow his farmland in 3 hours. Find the rate at which Mark can mow his farmland. One farmland for every 3 hours. Pretty easy. Number three. A baker can make a custom cake in 4 hours. Find the rate per hour at which the baker can make a custom order cake. One cake per 4 hours. All right. Number five. A soccer team averages a goal every 22 minutes. Find the rate per minute at which the soccer. Okay. So again, the thing to understand here is you can make a fraction out of it. You can spread it by a colon as well. One goal per 22 minutes. Okay. And again, when you have to translate these things or you have to convert them, that's where it's going to get more difficult. Again, they're just introducing to you something incredibly easy so they can show you more difficult things later on. So take the easy lessons and run with them. And so one goal per minute. Again, goals per minute. Again, as a fraction, it looks like this. Goals per minute, proportionally with separated by a colon, goals per minute. And again, in every single instance here, they're just giving you one. But you could have it where you have two or more. It could say something like, a baker can custom 3 cakes, in 4 hours. So then it would be more of a, but each of these instances is one per occurrence, per hour, per game, so again, every time in this entire lesson, the numerator is always just going to be one. Again, don't mean to insult your intelligence. I would imagine some of you are already done with all of lesson 29. Number 6, it takes Kelly 19 seconds to run up the hill behind her house. So one running up the hill per 19 seconds. Kelly is very fast. Number 7, it takes the content creator 2 hours to create her podcast. So one podcast for every 2 hours. A barista, verse 8, can make a cup of coffee in 5 minutes. So one cup of coffee per 5 minutes. So cup of coffee per minute. Okay. A washing machine can do a load of laundry in 56 minutes. So 1 to 56 minutes. Again, all these are very easy. So that being said, I told you lesson 29 will be the easiest thing we've done all year, probably the easiest thing you'll do all year. And we'll just call that good. Let's go to lesson 30. We'll probably finish a few minutes early today. Yeah, light work. And there's nothing earth-shatteringly difficult about number lesson 30 either. But I want to remind you of some things. Okay. When we add and subtract variables, we have to make sure the variables are exactly the same to the same degree, meaning exponent. Once we've established that fact, we can simply add and subtract the coefficients, taking into consideration all of the rules that we've learned about adding and subtracting negative numbers. Okay, so all those things we've already learned about adding and subtracting negative numbers apply. For example, for number 1, negative 3x minus x. Simplify this. So a couple things I want to remember. Anytime no coefficient is given, there's an understood coefficient of 1. So I have a negative 3x minus 1x. A negative 3 minus 1 is a negative 4, right? So the answer to number 1 is negative 4x. So again, not too terribly difficult. Letter A, okay? So make sure you just follow your rules of adding and subtracting positive and negative numbers because those rules apply. All right. For number 2, we're going to simplify. We have x plus 5x plus 12. Okay. So here, all we're going to do is this. I can add this and this together. That's my function is addition. I have an understood 1 there. Because these are the same, I can just add the coefficients. The coefficient is the number that precedes the variable. And we keep the variable the same. 1x plus 5x equals 6x plus 12. Okay, now, when I get to this part, I say, well, what do I do with the 6x and the 12? And the answer to that is this. You do absolutely nothing because you cannot add a variable to an integer or a whole number that has no variables. You also can't add, like a plus b is just a plus b. There's nothing you can do to that. If you have 2 variables, okay, and this is in its simplest form. You can multiply them together, but you cannot add them together, and you cannot subtract them from each other. Okay, and that's why distributive property is important to learn, and we've talked about those things already. So let's go to number 3. Again, this is not anything that is too terribly difficult, so take a light week, a light lesson, and we'll appreciate it. Now, part of simplifying when we do solving, I've told you, the first thing we do when we solve is we simplify. Part of simplifying is combining like terms. When we combine like terms, listen carefully to this, we do not use inverse operation. We only use inverse operation when we solve. When we combine like terms, we use the function that we see. Okay, so what I mean by that is this. I have this spot here, and this spot here, all separated by a function. In each of these functions, we have addition. Pardon my very poor penmanship of plus here. Let me rewrite that a little bit better. I can rewrite this one too because I can. So I am not using inverse operation here, meaning I'm not doing the opposite of my function. When I use inverse operation, when I solve, I use inverse operation. When I combine like terms, I'm simplifying and I use the operation at hand. So I have a negative 1x and a positive 3x. If I combine those together by adding them, it's 3 plus a negative 1, or basically a negative 1 plus 3. If you're going left to right, maybe that's a better way to put it. A negative 1 plus 3 is a positive 2. My coefficient remains the same. My value here, 8. There's no other value that has no coefficient, so it's just 2x plus 8. The answer is um, letter B. Yeah, 2x plus 8. That's my answer right there. Why don't you do 4 and 5 and send me over your answers to 4 and 5. Moses, I'm not sure if you have a worksheet because you weren't in class. So let me write this out for you. All right, those who submitted answers, you are correctamundo. I promise you, you'll get some tough work. If you say, Mr. Soto, oh, so easy. I'll remind you how bored you were in a few months when it gets to be a little difficulter. Yes, difficulter is a word. I can make words up as I go. Yes, that is correct. Everybody who sent over an answer has been correct thus far. So here I have this x here and this x here are going to cancel each other out. So it's 0x, which is just nothing. So then I do the 4 and the 15 together is just 19. So the answer to number 4 is letter C, 19. An x minus an x cancels each other out. Here, and I do this sometimes, especially if I have a very long problem that has several different variables to different degrees. I don't necessarily need to do it here, but I'll show you what I do. I'll sometimes underline these things. Like I'll go through and let's say there's this simplifying problem or even a solving problem that has a bunch of things together. Some with x's, some with x squared, some with y's, some with whole numbers. All the x's I'll underline once, all the y's I'll underline twice, all the whole numbers I'll underline 3 times. If there's like x squared or x cubes, I'll underline those 4 times. And that way I can keep myself and my signs right. Okay. So here I have a negative x and a positive 4x. Those two together would just be 3x. Okay. I have a positive 7 and a negative 10. Those two together would be a negative 3. 3x minus 3 is my answer, letter D. Okay. Now, it is possible somebody's still struggling with this, and then you think, well, Mr. Soto, I'm now kind of embarrassed because you said this is relatively easy stuff, and I still don't grasp it. That's okay. I don't mean to embarrass you, and I apologize if you feel that way. And if you are struggling with it, I'm just asking you to just hone in on the rules and try to understand the things I'm teaching you. And you can always send me a private message. You could say, Mr. Soto, I'm struggling still. Could you slow down? I won't call you out. I won't embarrass you, but you're more than welcome to send me over a note saying, can you explain that again? And so that being said, how are we doing thus far? Is there anybody who still doesn't quite grasp these concepts? Again, you can send me a private message if that helps your anonymity and such. Anybody? Okay. Now let's take these principles then, since you grasp them, and let's go to problem solving. Again, solving has an equal sign. An equal sign, your entire goal, at least this far in math, is to get the variable all by itself to the one coefficient to the one power. Okay. And so let me show you this. I have 6x plus a minus x equals 65. Okay. So let me give you a real life illustration of this problem. Okay. Let's say one of Mr. Soto's students, whoever, we'll say who's ever at the top on my participants list. That would be Abby. She's the first person on. She's the top person here. Let's say Abby works a job and she wants to find out how much money she makes per hour at her job. Okay. So she worked 6 hours one day and then they took 1 hour off for some random reason, and her check was $65. So now she has to figure out her rate of pay. That's what we're going to do right now. So we're going to say 6x plus a negative 1x is 5x. So we take the coefficients and we simplify. One way we simplify is by combining like terms. The like terms are the x's. Okay? So we combine those like terms. I do the function that I see. I don't do inverse operation until I solve. So once I get this problem in its simplest form, which it is now, I now will solve. And when I solve, I'll use inverse operation. I know you know this already, but I'm explaining it to you slowly to make sure you grasp these concepts, okay? And it's important to learn why we do what we do and the terms we use, because when the problems get a little harder, you need to know the functions at hand. So what I'm saying is this: 5 times the unknown value is equal to 65. Well, I don't know what that value is per se, so I'm going to use the inverse operation to get the coefficient variable all by itself. I'm not the coefficient, the variable all by itself. So I'm going to divide by 5. The reason I divide by 5 is because I'm saying I want to get rid of the 5 times x. So I divide by x, that gets rid of it. Anything I do to one side of the equal sign with inverse operation, I must do to the other side of the equal sign. So since I divided this side by 5, again, here I didn't do that on the simplifying because you don't use inverse operation on simplifying, and you don't do it to both sides of the equation. Only when you do inverse do you do it to both sides of the equation. So I divide both sides by 5. That cancels out. My x is now all by itself. 65 divided by 5. 5 goes into 6 one time with 1 left over. So I put the 1 here. 5 goes into 15 3 times evenly. So 13 is my answer. Abby, you make $13 an hour. All right. Let's try for you to do number 7. Send me the answer for number 7 when you get it. I'll write it on the board for anybody who is working. I caught that. You didn't catch that. I made a mistake and I caught it. Send me over an answer when you get it. You're all, Mr. Soto, why in the world would we do that if you're going to be doing it for us anyways? Because you need to learn how to do this. Oh, didn't mean to yawn. Sorry about that. Good. Good. Good, Kieran. Anybody else? That is correct, Abby. Anybody else? Is there anybody who doesn't know how to do this? Send me over a private message saying I'm still a little unfamiliar. Okay, I see one. Thank you. I'll show you in 1 second. Anybody else? Okay, so what we need to do is this. We need to solve for x. Anytime you see an equals sign, you are solving for x. We will use inverse operation eventually, but before we use inverse operation, we must simplify. One of the things we do with simplifying is combining like terms. So I have a negative 2x here and a positive x. I just need to say a negative 2 plus 1 is going to be negative x. So I combined this negative 2 and this positive 1 together to get negative x. I have negative x plus 5 equals 4. Now I ask myself, is there anything I can simplify? The answer to that is no. So now I'm just going to solve. I have this, I need to get x all by itself on either side of the equal sign. Every problem they've done so far, and that's not some, I don't love that about this curriculum, but every problem they've done so far, the variable has been on the left side of the equal sign. It doesn't have to be that way though, but because everyone's that way, you might be preconditioned to think that, and I don't want you to be. The x can be on either side of the equal sign. It doesn't matter. And the answer won't change either, and I'll show you that as we advance into Algebra 1 here. But right now, the x is on the left-hand side of the equal sign. On the same side of the equal sign as the x is, we have two problems that we need to care for. We have a value of a positive 5. We also have the x as a negative. Those two things need to be corrected. So since we're using inverse operation, we go backwards through PIMDIS. So we're going to subtract 5 first. Okay. So 5 minus 5. The reason I subtracted 5 is because I want the x to be by itself. And since it's a positive 5, I'm going to do the inverse of a positive 5, which is a subtracting of 5. So now it cancels out. So I have negative x is equal to 4 minus 5 is negative 1. Okay. And I showed you this before, but I'll show you the long way. And then once you understand the long way, you can, it is a very simple way to do this problem. Okay. All right, Annalisa, we will taco to you later there. Okay, so, and I'm going to show you the algebraic long explanation as to why this is. Well, first I'll do this. I'll just say that you can do this. You have a negative x equals a negative 1. These negatives just cancel each other out. So x is equal to 1. Okay. Okay. But let me show you why it's that way. There's an understood 1 here. So I'm going to divide this by a negative 1. And a negative 1 divided by a negative 1 cancels out. But in all honesty, it becomes 1 over 1. And anything over 1 is itself. So it's just 1. And there's an understood 1 in front of the x, so it's just there. That's the total algebraic way why that is. But because I needed to divide this by a negative 1, I must also divide this by a negative 1. So x equals negative 1 over negative 1. The negatives cancel out, so it's 1 over 1. And 1 over 1 is just equal to 1. I know that sounds very, labor intensive or, too much information type. But I do think it's important for you to see why these things are, because when they get harder, you might need to understand the rationale behind that. Okay. Let me show you one other thing you could do as well, because we have lots of time. I'm just showing you things you can do. mathematically speaking. I've told you before that I don't like to keep the x's negative if I can. So I could theoretically do this. I could add a 1x to both sides, or just an x to both sides. Okay? Because I don't want my x to be negative. Okay? I'll just continue my work. You'll watch, I'll get the same exact answer. Now I subtract 4 from both sides. 5 minus 4 is 1. 1 equals x, or x equals 1. Why did I do that? The only reason why I would do it that way is if I was trying to keep the x positive. Now, let me share one more thing with you. Again, this is a relatively easy day, so I'm explaining a few things that are important to understand in math. When I had this problem like this, let me just give you another example. Let me show you something totally different. Okay, in this particular problem, the reason I divide by a -2 is because I'm actually splitting the 2 from the x, right? But in this particular problem, let's say I had 2x plus 4 equals 8. Okay. Again, if I want to take this entire 2x over to the other side, I am not going to divide by 2. I'm going to add 2x to both sides. The reason being is I'm taking the 2x from one side, the entire thing to the other side. So now I have 4 is equal to 8 plus 2x, subtract 8, subtract 8. -4 is equal to 2x, divide by 2, divide by 2x is equal to -2. So I'm just explaining this to you because these are things you're going to need to learn in math. If I'm separating the coefficient from the variable, I do the inverse operation, meaning I divide, because by definition, a number and a letter implies multiplication. The inverse of multiplication is division. If I'm taking the whole entire amount from one side to the other side, I'm basically, this is subtraction here. So since I'm not splitting the 2 from each other, I need to add 2 to both sides, and that's why you do that. So that's a little bit too much information, I gather, but I wanted you to see that. Let's do this. Let's try number 8 and 9. Is anybody thoroughly confused by the last 3 minutes that I just did? It's not my goal to confuse you, and I don't mean to do that, but I just take an opportunity on an easier lesson plan to explain some things that are very important moving forward in math. Okay, so combine your like terms and solve for y on number 8. And then number 9. All right, I like it. Me like it. Me like it. Me like it. If you've sent me over an answer in the last minute, those are all correct. For those who did send me over answers. Yes, good. Still correct. Still correct. Still correct. Still correct. Here's number 8 for you, for those who are maybe didn't get it or didn't send over an answer. 10y plus 3 minus y equals 30. I combine the like terms. A 10y positive and a negative y combined together equal 9y. So 9y plus 3 equals 30. It's now in its simplest form. I use inverse operations. So the inverse of addition is subtraction. So I subtract 3 from this side. Anything I do to one side of the equal sign, I must also do to the other side of the equal sign. 30 minus 3 is 27. So 9y equals 27. I now must divide both sides by 9 to split to free the 9. So 9 multiplied by an unknown value is 27. I divide by 9. Anything I do to one side of the equal sign, I must do to the other. 27 divided by 9 is 3, so y equals 3. You can always check your work back in the original problem. 10 multiplied by 3 plus 3 minus 3 equals 30. Well, this is 30 plus 3 minus 3 equals 30. 33 minus 3 equals 30. 33 minus 3 is 30, and 30 is equal to 30. And you probably wouldn't do all that if you were actually solving the problem. I mean, you could just say this 30 together here, and this just 3 minus 3 is 0. 30 plus 0 is 30. But you can check your work always. Number 9, a 7x and a 1x is an 8x minus 1.5 is equal to 14.5. So I'm going to add 1.5 to both sides. You have 8. This cancels out. This is going to be 14 and a half plus 1 and a half would just be 16, because 5 plus 5 is 10, right?
Wait, I think you said plus 4.5 instead of 1.5.
You'll have to watch the recording and see if I did do that. I don't know if
Okay.
I get a for saying the wrong thing. Do I get a hash mark for saying the wrong thing?
Yeah, you have in the past.
Oh my goodness. Okay, well, your job is to, because I don't know, is to watch the video tomorrow. If indeed I did, and you can corroborate, this is at the about the 37-minute mark. So you don't have to watch the whole thing. Just fast forward about the 37-minute mark. See if I did say whatever you said I said, and then if I did, then you can give me a hash mark on Tuesday. Okay?
Yeah.
4, 5, 6. So 16.0 is basically just 16. Divide by 8, divide by 8, x is equal to 2. All right. Number 10, we should be able to do in our head. 8x minus x is 7x. Divide both sides by 7. X is going to be equal to 7, because 7x equals 49. X is equal to 7. All right. Yep. Good job. All right. Again, this is not the most difficult stuff we've ever done in our uh, time here. So, but all that being said, it will get a lot tougher. So make sure you're grasping these easier concepts. And if you ever need any one-on-one help, I start this Zoom link at 8:45. I know our class doesn't start till 10, but you are more than welcome to jump on at 8:45. Between 8:45 and 9 o'clock, I have one-on-one help for anybody who needs it. That's a 15-minute window. Then my 9 o'clock class will start. You can exit the Zoom, and then you can actually get back on at 10 o'clock for our class. As far as the hardest I've ever taught, um, curriculum or the actual, yeah, in the in, I can't throw anybody under the bus, but I do have at least. Uh, I'm thinking of people right now. I can think of some of the smartest students I've ever had, the hardest or the most difficult students I've ever had. I've had the ones who've struggled the most as well, and but I will have to recuse myself from such. I don't want to get myself. I don't want to self. I can plead the Fifth Amendment, Kieran, and not incriminate myself, especially because I'm recording right now, and I'd hate to have this be used against me in a court of law. So, uh, yeah, I've had some hard ones. Uh, Six and seven is my hardest numbers. Okay. All right. We're gonna let you go 2 minutes early, and we'll call that a class time, and we'll table the difficult, the hard, and the easy, and the smart students for a later class. And let me end the recording here before I get myself in trouble.